Pollination is a vital link in the food chain and innumerable ecosystems. And bees, wild and managed, are Earth's most important pollinators. Monitoring programs indicate unusual rates of bee losses all over the world, but particularly in Europe and North America, threatening both food security and biodiversity. There is no single reason. Bees are affected by many factors, notably chemicals such as pesticides, pests and predators, climate change and habitat loss, poor nutrition. Not all bees are affected in the same way by these factors. For example, domestic bees used for crop pollination and honey production are likely to be more affected by farming and beekeeping management practices, while wild bees may be more vulnerable to climate and habitat changes. Stressors acting together can be far more damaging to bees than when they act alone. Which is why EFSA is running a project to develop a holistic approach to the risk assessment of multiple stressors in bees must be, starting with honeybees.
We needed to understand what a healthy honeybee colony looks like. EFSA established a working group, we called it Healthy Bee, with the task to develop a toolbox that systematically describes the characteristics that define the health status of a colony. This toolbox can be used by anyone involved in collecting, reporting, and also analysing data on honeybee colony health under field conditions.
The toolbox considers what is going on outside the colony, colony habitat and land management, weather conditions, beekeeping management practices, predators, including new invasive species such as the small hive beetle and Vespa velutina, or the Asian hornet. What is going on inside the colony? Is the queen present and healthy? Are there sufficient worker bees, and are they carrying out their tasks effectively? Is there enough food, particularly honey and bee bread? Are there signs of disease, infection, and infestation? Are there signs of contamination of in-hive products, wax, bee bread, nectar? Is the colony productive? Is there honey for harvesting, propolis, and so on? Each element can be assessed against a set of criteria to establish the health status of the colony.
Next, we set out to design a computer model to help assess the risks posed to bees by stresses, particularly pesticides and infectious agents like Varroa nosema, acting in combination with the environment.
The model consists of a number of interconnected modules that reflect the elements of the toolbox, such as the condition of the colony and presence of in-hive products such as nectar, honey, pollen, and bee bread, the foraging activity of the honeybees, land structure and management, weather conditions. On top of these base modules are additional modules that address exposure to and effects of pesticides, beekeeping practices, and biological agents such as the Varroa mite and associated viruses, and nosema. The model could be expanded in the future to take account of exposure to multiple chemicals and other biological agents such as invasive species.
To test the computer model, we will need real data collected from at least 3 European regulatory zones, representing different landscapes and environments. Wider data collection and sharing across the EU will then be absolutely key to realising the long-term potential of the must-be framework.
We can envisage a future where beekeepers examine their colonies using the criteria from the toolbox, upload the information to an open access database serving multiple stakeholders, and risk assessors and managers use the predictive model to determine the risks to honeybees from exposure to pesticides in combination with infectious agents, beekeeping practices, landscape, and weather. Further down the line, the model could be used to identify and monitor trends within and across different regions.
None of this will be possible without the commitment and cooperation of EU and national institutions, beekeepers, farmers, researchers, animal health specialists, NGOs and industry experts. It requires a true European bee partnership